Question 3, a van of mass 750 kilograms moving a straight horizontal road, blah blah blah, moving velocity v, resistance to motion, lambda v newtons, the engine's working at 18 kilowatts, when v is 15, the acceleration is 0.6. So, we need to work out the driving force to start with. So, power is equal to force times velocity. The power is 18,000 watts. The velocity is 15. So the driving force is 1200 newtons. If we now draw a picture, there's our van. It's got a 1200 newton force pulling it. The resistance is equal to lambda v newtons, and since v is 15, that's going to be 15 lambda newtons that way. It's accelerating at 0.6 meters per second squared. So if we now resolve in the direction it's accelerating, 1200 minus 15 lambda is equal to the mass 750 times the acceleration 0.6, which gives us that 1200 minus 15 lambda is equal to 450. So therefore lambda is equal to 50 as needed. The van now moves up the straight road at inclined angle where sine alpha is a 15th. So now it's going up here. At the instance when the van is moving at the v meters per second, the resistance motion is 50v. When the engine of the van is running at a constant rate of 12 kilowatts, the van is moving with a speed of v meters per second. So here's the van going up. So again, we have to do the same old thing. First we need the driving force. So power is still equal to force times that. The power is still... Now the power now is 12 kilowatts. Is equal to the force that I want to know times the velocity, which is v. So the driving force is 12,000 over v. The resistance to the motion is 50v. And there's the weight of the van we have to think about as well. The weight of the van is 750 g, but because we're going up into the plane, we need the component of the weight which is going to be parallel to the plane. That angle there is alpha through various angle laws. So this component of the weight is going to be 750 g times sine alpha. And we know from the question that sine alpha is a 15th. There's also the normal reaction force, but I don't think we need it in this question, but we'll put it in for completeness. So, with all our forces in, it's going at a constant speed, so the acceleration is 0. So if we resolve parallel to the plane, the only force pulling it up the plane is the driving force, 12,000 over v. That's been resisted by the force pulling it down the plane, 50v. It's also being resisted by the component of the weight acting down the plane, 750 g times sine alpha, which is a 15th, and that is equal to the mass of the thing, 750 times the acceleration, which is 0. So that is equal to 0. if we rearrange, or if we simplify it and rearrange it, we will get 12,000 over V minus 50V minus 490 is equal to 0. So that will give us that 50V squared plus 490V minus 1200 is equal to 0. Solve that however you like, but I would suggest a calculator, and you get that the velocity is 11.3 meters per second. We can ignore any minus answers because they don't make sense in context of this particular question.